Good morning, class. Happy Thursday. You are almost done with your second week of the school closure, so hang in there. Remember, your assignments are due tomorrow on Friday. Quite a few of you have already been turning in assignments, have been working on them, so thank you very much for doing that. Make sure you finish. If you haven't started, you need to start now, and you need to make sure you get those assignments in. And I know you have other classes and you're sharing computers with brothers and sisters, but if you haven't started biology, you should get going now. All right, let's get to this video. 15.1, Evidence for Evolution and Natural Selection. And so I've done videos on evidence for evolution, and in today's video, we are going to look at our first lesson objective, summarizing Darwin's theory of natural selection. So, Darwin, British scientist. He was going to be a doctor, but didn't like it, was called dumb, and so he went into the business of natural science, and now he's one of our scientific legends. If you want to learn more about Darwin, you can. I'll post a video, and you can watch it, and you can learn about his life. But I'm not going to explore Darwin's life. We're just going to go over his observations of the beagle and how that led to his theory of natural selection. So for 5 years, he went on this voyage through South America and Australia and the Indian and Atlantic Oceans. And on that voyage, he made some key observations. One, he found fossils in places that didn't seem to match where they're found today. So ocean marine fossils found on the tops of mountains. Okay, just like with us finding marine fossils in the Central Valley, led to a conclusion that the Earth is changing. That plate tectonics and geologic forces are constantly changing Earth, and Earth throughout its history has been changing. Also, he found fossils that look similar to living species. So in South America, he found giant armadillos that are called Glyptodon that resembled modern armadillos. So it looks like, if you compare these two, that they've been changing over time. Just like when in other videos, I showed you transition fossils of whales and horses. If you compare the fossil record, similar organisms in the past seem to show that there's some change happening. Also, he found similar species next to each other. So these two emu ostrich-like birds, the rheas, so greater rheas and lesser rheas, they're found in ranges next to each other. Now, we go to the Galapagos Islands. So an island chain on the western side of South America next to Ecuador. So this is a diverse island chain with lots of different environments for organisms to live in and try to survive in. So on this island, he observed that there were similar species living next to each other, like the rheas. So you have a saddleback tortoise and a domed-back tortoise. And he also noticed that on those islands, the differences between the similar organisms, well, their differences seem to perfectly match the environmental differences. So if I look at finches, you have seed-eating finches with really large, thick bills, and they do a really good job of crushing thick seeds and digesting them. Whereas you had finches on islands with lots of cacti, their bills are a little longer so that they can reach inside of cactus flowers and eat the nectar. And then you had islands with not as many seeds and not as many cacti, but lots of insects, and their bills seem to be really long for like probing inside of trees and rocks and grabbing insects, or getting insects from trees, so bills that can help them grasp onto insects. So the bill matched the environment. So similar species living on islands next to each other, but having variations that help them survive in their particular environment. Let's go back to the tortoises. So he likewise noticed the tortoises, their differences match their environment. Now if I look at the dome-back tortoise, there's lots of vegetation on the ground. And so it had a domed shaped shell, and it would just graze on the vegetation on the ground. But this saddleback tortoise, its island, there's no vegetation. It's rocky, and all of its vegetation is in trees and bushes. So its shell has this little ridge that allows its neck to reach up and grab and eat vegetation that's a little higher off the ground. So again, the tortoise shells seem to match the environment and help that particular tortoise population survive. So all of those observations led to Darwin's theory of natural selection, in that species adapt over the course of generations to their environment. Like the finches, over the course of time, they have been adapting and changing to help them survive in their environment. And this theory happens over a long period of time. So a long period of gradual modification leads to the diversity of life. That leads to the diversity of finch species we have. That over the course of many thousands of generations, little changes that help these finches survive in their environment led to all of the different bill shapes and the different species we see on the Galapagos Islands. Now, for natural selection to happen, the trait you're looking at, beaks, tortoiseshells, it has to be genetic. It can't be something that the tortoise changed. So if tortoiseshells, the mama or the dad tortoise, when the baby tortoise was born, it lifted its shell up and like molded it, that wouldn't count for natural selection. The tortoises had to be born with a particular shell shape. Also, variation has to happen in the trait. So if all the tortoise shells were the exact same, there would be no way for change to happen. You have to have multiple alleles, different alleles, for natural selection to work. And then there has to be competition for limited resources in the environment. Okay, and the sad truth is not every organism is going to survive. Now, in that competition, one of the variations has to give more fitness to an individual compared to another. So with the tortoiseshells, if you have that ridge, that variation, if it makes you more fit, it helps you eat more, you're going to survive more than tortoises that don't have that same ridge. And if you are more fit, you have the more fit variation of a trait, say the ridge tortoise shell, you're going to be able to make more babies. You're eating more, you're surviving better, you're more attractive to a mate, so you're going to make more babies. And so that means over the course of generation, that variation that is more fit for the environment is going to take over on the population. So over time, you're going to see more tortoiseshells that have that ridge, or more finches that have really thick beaks to help them crush seeds. Now, keep in mind, okay, survival of the fittest, natural selection does not mean the strongest. It means that you're better fit for the environment. Okay, you're better for a particular environment. Now, in the next example, now these are all developed traits, so this truly is not a perfect example, but it is an example of how different environments give different fitness. Now, I have 3 athletes who are the best or have been the best in their field: Rafael Nadal, Michael Phelps, LeBron James. Now, if these two were to play Nadal in tennis, they would get butchered. Nadal would go ace after ace after ace and make them look silly on the tennis court. But if Nadal and LeBron were to race Michael Phelps in a 100-meter freestyle, he would crush him. He would go there and back before they even made one lap. And similarly, if these two went and played LeBron James, well, the king would reign and he would posterize both of them. So, even though these 3 in their particular environment, the tennis court, the swimming pool, and the basketball court, are most fit, if you put them in a different environment, they stop being the most fit. It changes. So, likewise in natural selection works in a particular environment. And if you move an individual to a different environment, natural selection could change that population. Now, looking at examples. So, with one, we have some butterflies. So first, you notice we have some genetic variation. We have a trait that's inherited, butterfly color, and we have two alleles, two versions. So there's competition for resources. There's limited space on this tree bark, this tree trunk, and one trait is better fit for that environment. So the brown caterpillar is able to camouflage a little better. So the birds are going to go eat more of the yellower caterpillar. And so these brown butterflies are able to survive and lay more eggs and have more brown butterfly babies. So over the course of generations, you get more yellow butterflies. But this is about the environment. And you can imagine if this bark was a lighter color, more yellowish, it might get flipped. The yellow would be better able to survive. So this population would be selected more for yellow. Okay. So another example, beetles. So you have a population of green and orange beetles, and the crows tend to eat more of the green beetle. So you have variation, and there's competition. The orange ones are winning that competition. They are more fit to survive, so they are going to reproduce more, and over the course of generations, the population changes from mostly green to orange. Now, one type of natural selection that humans do, we make chemicals that kill organisms we don't like. Okay, antibiotics for bacteria, pesticides for insects, and herbicides for weeds. So if you have a field with weeds, so you have variation, you have some weeds that do not have resistance, and then a few that do have resistance. And so there's competition to survive, and now this environment has changed, and there's herbicide being sprayed. There's poison everywhere. So the ones that are resistant to the poison, they're going to survive more often and produce more seeds and make more weed babies. So over the course of generations, you're going to slowly get more resistant weeds growing, and that in time, as that herbicide is selecting for the resistant weed, you get a population of herbicide-resistant weeds. And with humans, natural selection happens in humans too. And a fun example is with newborn baby weight. Okay, most newborns are between 6 and 8 pounds. Okay, so really, really tiny babies don't survive as well. Okay, if you're 1 or 2 pounds, your chance of surviving is pretty low. There's a high chance you die. Okay, just you're too small to survive. Maybe your organs, your body's not fully developed, and so you're out in the real world, and it's going to be tough. If you're too big, well, if you're a 12-pound baby, there's a higher chance that you're going to kill mom because you're just big, and you could cause complications at birth. And well, if your giant baby weight kills mom, then you're all alone, you're by yourself, or you're just with dad, so it's going to be a little harder to survive. So babies that are somewhere around 7 pounds, they end up surviving more, reproducing more, and over the course of generations, we've seen birth weight stabilize at around 7 pounds. Okay, so in conclusion, Darwin's voyage gave him observations to support the theory of natural selection. Okay, a struggle to survive in competitions for resources in a given environment drive descent with modification, slow changes, slow evolution, and then beneficial heritable variations will be passed down more often, which will evolve a population over many generations. Alright, I hope this helps. Keep finishing your work. Stay positive. Wash your hands. Stay safe. Bye.